Hi there students, I feel a bit bad for being off sick 2 days in a row this week, so I thought I'd give you a quick rundown and some examples of the sort of things that are going to be in your test on Friday. Now, as you can see here, there's 4 topics that are, or 5 that are going to be assessed. Basically the first 3 ones in collecting like terms, expanding single brackets and simplifying, and expanding double brackets and simplifying. We could put those under the umbrella of algebra. Whereas finding the volume of prisms and tricky problems involving the volume of prisms, essentially the same thing, we can put each of those excuse me, under volume. So that's where your, I guess, like the content comes from. It's partially an algebra test, partially a volume test, and it's going to be worth 20%. The only topic I'm not going to go over directly is simplifying by collecting like terms, because that forms part of every section, so to speak, that you do with the algebra, so they'll be covered in due course. Okay, so when we've got an example like this, so 2 bracket n plus 3 close bracket, what we're actually saying is we've got 2 lots of n plus 3, and if we made a quick note up here, it'd just be like saying I've got 1 bracket of n plus 3, and I've got another bracket of n plus 3. So if we were to remove the brackets there because we're adding them, they don't need to be there, and collect all the things that we can add, 2 lots of n is 2n, and 3 add 3 is 6. Cool. Now that's not going to suit us if we've got more complicated things like the ones just here. We're not going to write 2 lots of this bracket on the right and 3 lots of the bracket on the left. What we can do instead is say, well, I've got 2 lots of everything that's on the inside of this bracket, which means I've got 2 lots of n, so 2 times n, which is 2n, and 2 lots of the 3 that's on the inside, so 2 times 3, which is 6. And that's something in maths that we call the distributive law. We take whatever we've got on the outside of the bracket and multiply it by everything that's on the inside of the bracket, essentially. So say for example number 2, we've got 3 lots of a plus b plus 2 lots of a take away b. So we'll use our distributive law again. 3 times a is 3a, 3 times b is 3b. So we've got 3a plus 3b. Then move on to the next bracket, 2 lots of a, so 2a, and then 2 lots of negative b. So we've got a positive at the front in 2 and a negative in the bracket in negative b. Positive times negative is always a negative, so 2 times negative b is negative 2b. Now this is where the collecting like terms simplifying bit comes into play. So we've got 3, well I'll just reorder it first because I've got different things that I'm adding together, so the order that I write in doesn't matter too much. So I'm going to go 3a first, I'm going to add this 2a, I'm going to add this 3b, I'm going to subtract this 2b. So now I've got my different variables together in the same places. So 3a plus 2a, that just means, well, I've got a, and a. It's 3a, a plus a plus a. I've got 2 a's, a and a. So 3 lots of a add 2 lots of a has to be 5a. And 3 lots of b, 1, 2, 3. Take away 2 b's is just going to leave me with 1 b. That's an important point on collecting like terms. They have to be absolutely identical for you to add and subtract them. So just as a quick extra example, if you had something like 2b squared plus 3b cubed plus 4b squared, let's say, that means that really you've got 2 lots of b squared, you've got 3 lots of b cubed, and 4 lots of b squared. Now the temptation there is just to add all of them up together and say something like 7 on like something else b to the powered 5 or whatever, which is a common mistake. But what you actually, the only thing that you can do when you're adding these is to add the 2 lots of b squared and the 4 lots of b squared. I'm going to have to write this up here, which is 6 lots of b squared. And then you've got these 3 lots of b cubed left over. So that's how you would simplify something like this. You can only add or subtract variables when they're exactly the same. Doesn't matter if they're similar looking, like these b squareds and b cubes, they have to be identical. Alright, one more tricky example just to finish off. The reason that it's tricky is that this one uses much more in the sense of negative signs, which is something you have to be careful for. So 5x times x is 5x to the power 2. Now 5x times negative 2, well, a positive times a negative will give us a negative. So our thing for that is going to be negative 10, because 5 times negative 2 is 10, and then x. Now for this next one here, it's take away 3 lots of 2x take 3. So we treat this here as a negative. So negative 3 take 2x. So negative 3 times 2x is going to be negative 6x. Negative 3 times negative 3 is going to be positive 9. And then we can simplify that by saying 5x squared. 10x take away 6x is going to be negative 10x take away 6x is negative 16x, and then that plus 9 is going to be there as well. So we've collected the like terms in the expressions that finish in the same thing, so x and x in this case. X squared is its own thing, and the 9 is its own thing as well. Cool. Alright, expanding double brackets. The way that we learned to do this in class is to remember the acronym FOIL. This is generally the best way to do it, which stands for first, so multiplying the first two in each bracket together, and then O for outside, so the 2 terms on the outside, so the first one in the first bracket, second one in the second bracket, inside, 2 in the A for this one, the 2 that are on the inside, and then last, as in the opposite to first, so the last terms in each bracket. So, for this first one here, A times A is A squared, so that's first. Outside, A times 4 is 4A. Inside, 2 times A is 2A. And then last, 2 times 4, which is 8. So now we have some simplifying to do. A squared, 4a plus 2a is 6a, and then plus 8 as well. So we can't simplify it anymore, and that's our final answer. Alright, next one. B squared times 3b is going to be 3b to the power 3. B squared times 2 is 2b squared. 3b times c is exactly that, 3bc. And c times 2 is 2c. So now we look carefully and see if we've got any like terms between them. This one ends in b cubed, this one ends in b squared, this ends in b times c, and this one ends in c. So that's actually our final answer. We can't make that any more simple than what it is right there. I'm just going to make sure this is still recording, because that would be devastating. Yep, still going. Super duper. Alright, these next two are not really harder, but they look more confusing. Just remember that if you've got something like p take away q squared, when you have anything squared, so say 4 squared just means 4 times itself, a squared means a times itself. It's no different with these brackets. It's just the bracket that's given in the expression multiplied, nearly did my p wrong, multiplied by itself. So now we've just got a double bracket problem that we can expand as normal. So p times p is p squared, p times negative q is negative pq, negative q times p is negative, we'll call that pq as well for reasons I'll show you in a second, and negative q times negative q is positive q squared. Now the reason I've written these in alphabetical order is that it was convenient for one, but it also makes it a little bit easier to notice that we can simplify these two. So it'll be p squared take away 2 lots of pq, because pq take away pq is 2 lots of pq negative, plus q squared. Cool. And same applies to the next one. 2a plus 4 squared is going to be 2a plus 4 multiplied by 2a plus 4. 2a times 2a is, 2 times 2 is 4, and a times a is a squared. 2a times 4 is, excuse me, 4a. 4 times 2a is 8a, and 4 times 4 is 16. Then simplifying, 4a squared plus 12a plus 16. Super. Alright, now we've got a couple, and there's a couple that are similar to this on the test, so I thought I'd throw these in there as well. And this was part of the revision sheet that you did either today or yesterday. I don't remember, unfortunately. It's when I wasn't here, basically. But you have to find the area, and there's something similar on the test, so it's worth doing these, but you have to find the area of these two shapes. So you're not going to get a definitive answer like the answer is 16 centimeters squared or something like that. Your answer is going to be in algebra form. So using this first one as an example, you'd first start off by recognizing that this is a rectangle, and the area of a rectangle is given by length times width. So for this one, our length is 3w plus 2. Our width is 2w plus 4. Expanding that, 3w times 2w is 6w squared. 3w times 4 is 12w. 2 times 2w is 4w, and 2 times 4 is 8. Simplifying, 6w squared plus 16w plus 8. Cool, so yes, that's not an actual this many centimeters squared or whatever, but it is an expression for the volume. It doesn't matter that we don't know what W is because it's an algebra question. There's going to be things that we don't know, so don't worry too much about that. Now, this next one is slightly trickier, and I will explain it to you now. So we're trying to find the area of this it's kind of like a picture frame sort of thing. It's like just the area of this border that we want. So what you could think of that is it's the big square that's on the outside, if that whole thing was taken out, minus the area of the smaller square that's being like pushed out of the middle, kind of like a picture frame, I guess. So we're going to need the area of the big square, which is m plus 4. And these are squares, by the way. That might not have been immediately obvious, but I promise that they are. So m plus 4 to the power 2. And we're going to subtract from that m plus 2 to the power 2 as well. The reason it's to the power 2 is that the area of a square is, well, it's whatever the length of the side is squared, because it's similar to a rectangle in its length times width, but the length and the width are the same. So for this one, we've got, well, I'll just do this relatively quickly. So m, if we pretended there was two of these, first one would be m times m, which is m squared. Then we'd have two lots of 4 times m, which would give us plus 8m. And then we'd add on to that 4 times 4, which is 16. Then we want to take away the result of, I'm just going to put brackets to illustrate the point, because we want to take away everything that's in the next set of expanded brackets. So m plus m to the power 2 is m to the power 2. 2m plus 2m would be 4m. And then 2 times 2 would be 8. So we've got everything in this first bracket, and we want to subtract everything in the second bracket from that. So m squared take m squared is nothing, that cancels out. 8m take, oh, I've missed my m there, that's okay. 8m take away 4m is 4m, and 16 take away 8. No, Mr. Barker, that's silly. 2 times 2 is 4, not 8. Okay, so 16 take away 4, which is 12. So and again, it doesn't matter that you've not got something centimeters squared or whatever, because your actual answer is, for the area of that, is 4 times m, whatever m happens to be, plus 12. And sorry for that little mistake, that looks messy now. But like I said, I'm still sick, so hopefully there's not too many mistakes. Okay, volume of these prisms. So now we're out of the algebra section and into the volume section. So the way that we calculate volume is to take the area of the cross-section and multiply it by the height, the length, the width, or whatever you want to call it. Generally, we just refer to it as height because it's the volume, sorry, the area of the cross-section multiplied by whatever the other dimension is that we've not used. So it might not necessarily be how tall the shape is, it might be how long it is or whatever. Being a prism is going to have the same cross-section all the way through. So we find the area for this cross-section, and for this example I've got a triangular prism. So the way that we find area of a triangle is to multiply the base by the height and divide it by 2. So So for this one, base is 12 multiplied by 10 is going to be 120, obviously, divided by 2. That gives us the area of our cross-section, this area here. Multiply that by the height, which is 30. And then I'm going to show you this, how you would actually enter it on a calculator. And I know I've said you're not allowed to use your phone recently, but I'm going to do it because it happens to show it best in the camera. So I'm going to go 12, what I'll probably actually do is go bracket 12 times 10 divided by 2. And then I'm going to multiply that by 30. Gives me an answer of 1800. And then I look for my units. Everything has been in centimetres, so that's going to be centimetres cubed. And cubed to represent that this answer is volume, it's in 3 dimensions. Okay, next one, exactly the same deal, except we've got a composite solid to deal with. So volume is area times the height of the shape. So what we're going to do here, our area is going to be made up of 2 different parts. We've got the area of this square. So area is going to be 10 squared, because 10, see these marks, they mean that they're all the same length. 10 squared, that gives us the, let's write up here, area is going to equal the square plus the triangle, which is what we're doing here. So 10 squared gives us the area of the square, and then adding on to that the area of this triangle. No, that's going to have a height of 10 centimetres, because it's the same as that. No, the base length is going to be, well, if it's 18 all the way across, and between here it's here and here it's 10, it's got to be 8 the rest of the way, 8 centimetres, because the 10 that's here and the 8 that has to be here gives us 18 in total. So, area of that triangle is going to be 18 times 10, base times height divided by 2. And we're going to multiply that by the height, so just the other dimension that we've not used, which is 8 centimetres. Now you'll notice that there's a 12 here, and that's a deliberate red herring that's from the question. So that gives us this length here. And if we're trying to find out the perimeter of just this shape, that information would be important, but you've got to think of it in terms of using all of the dimensions, as in like that 12 for this length here really is the same as this length there. We need the other dimension, which is this 8. Alright, so in the calculator I would go something like this. I want the result of 10 squared, and I'm going to add on to that 8 times 10, 18 times 10 rather, divided by 2. You know what, 18 times 10 is 180, divide that by 2 is 90, so I'm just going to add that on myself, then multiply that by 8. That gives me an answer of 1,520. Again, look at the units, centimetres cubed. Easy, hopefully. Okay, last question. So this delicious tin product is 7.5 centimetres wide and 10.9 centimetres tall. What is the volume? And I've based this on some real measurements for these Heinz Beans creations. If you haven't had them, you have to give them a try because they're really cheap and they're really filling and really delicious. So I really sing their praises to anyone that will listen in the staff room. Anyway, the point of doing this is twofold. We've done a question on composite shape, so working out the area of something where we need to use the area, I guess, or like the formula for different types of shapes. So we've covered rectangles and squares, we've covered triangles, and now we need to cover circles as well. So you need to really have the area formulas for triangles and circles memorized to do this test. Anyway, so I've drawn a little diagram here to help me out. You may or may not be given one in the test, but it's probably better to practice it anyway. So this delicious tin product is 7.5 centimetres wide, so that means it has a diameter of 7.5 centimetres and a height, let's say, of 10.9 centimetres. That's not very neat. That's okay. What is its volume? It's the same deal as normal. The area, the volume of a shape is given by its cross-sectional area multiplied by its height. No, the area of a circle is given by pi times the radius squared. But you have to be careful because for this shape you've been given the diameter, not the area for this one. So our area for this shape is going to be pi multiplied by half of 7.5, so 7.5 divided by 2. And that's whole thing squared, so whatever the result of that is squared. And we're multiplying that by the height, which is 10.9. Now in the calculator I'd do it like this. Let's check my time. Okay. So 7.5 divided by 2 is something you might want to start with just to make it easier. Just make a note that it's 3.75. You could do that in your head quite easily, obviously. So I'm going to go pi multiplied by 3.75 squared, which gives me a cross-sectional area of 44.18, which looking at this seems about right to me. I'll check to see if it makes sense. And I'll multiply that by the height of the shape, which is 10.9 centimeters. And I'm just going to pretend that I'd written in the question that I wanted you to give your answers to 2 decimal places. That's what I'm going to do here. So my answer is going to be 481 point. Well, I'm going to write the first decimal place, which is 5. I'm going to look at the digit after the second decimal place, which is 7. So I'm going to round up the 4 to a 5. And correct units, obviously, centimeters cubed. Okay, that pretty much covers everything that you need to know. We've done revision in class. We've covered all the actual content. There's no surprises in there. Just make a point of maybe memorizing the area of a circle is given by pi times the radius squared, and make a point of remembering that the area of a triangle is base times height divided by 2. And remember the FOIL thing for double brackets. I definitely remember that. And remember that you can only collect like terms if the things that you're adding or subtracting are identical. And remember that a negative times a positive is a negative. So positive times positive is positive, positive times negative is negative, negative times positive is positive. Oh no, it's not negative, and negative times negative is a positive. So remember that as well. But those questions are a pretty good guide to the sort of things you want to know. All right, see you Friday, hopefully.